You've all heard about artificial intelligence, or AI, right?
AI. You mean artificial intelligence?
It's a staple in the science fiction world, where seemingly innocuous computers suddenly become self aware, and, for whatever reason, they become an existential threat to all of humanity. But what is machine learning? Is machine learning the same thing as AI? Or is machine learning a subset of AI? Or is it the other way around? And what is this thing called deep learning? Speaking for myself, AI, machine learning, and deep learning seemingly came out of nowhere during the past few years. But in actuality, these fields of study have been around for decades and can trace their roots back to the dawn of computing. In this new 13-part series, we'll focus on machine learning, but by the end of this series, you'll understand the difference between AI, machine learning, and deep learning, so that you'll be able to navigate within this rapidly developing world. You'll also get an introduction to various Julia packages that you can use to create your own machine learning code using the Julia programming language. Will your newfound knowledge put all of humanity at risk? Well, let's find out. Welcome to Julia for Talented Amateurs, where I make wholesome Julia tutorials for talented amateurs everywhere. I am your host, the Dabbling Doggo.
I dabble.
Before we get started, just a bit of housekeeping. Starting this year, channel members will get early access to all new videos. These previews will not be monetized, so hopefully YouTube won't put any ads in them. For this series, new videos will be released to the general public 1 week after they are made available to channel members, at which point monetization will be turned on. If you're a channel member, I thank you for your support, and I hope you enjoy this added benefit. If you're not a channel member, don't worry. All videos will eventually be released to the public, so you won't miss any episodes. And just who am I? I am not a machine learning expert, nor am I a machine learning professional. I do not have a PhD, and when it comes to both coding and machine learning, I am completely self-taught. I taught myself how to code by absorbing information that is freely available online. In the same way, I am teaching myself about machine learning by finding information that's available for free online. As a way of giving back to everyone who has generously provided their knowledge online for free, I'm producing these videos to hopefully make that learning process a little more efficient for anyone who may be interested. If I can learn it, so can you.
You can do it!
This series is intended for students, hobbyists, and amateurs who have no machine learning experience. This is not a professional certification program, so don't expect anything like that. This material, and this entire YouTube channel, quite frankly, is for regular folks who just want to learn something interesting and want to have some fun while doing it. But there are some knowledge prerequisites. For this machine learning tutorial series, I'm assuming that you're already familiar with the basics of Julia. If you're new to Julia and would like to learn it, please watch my Julia for Beginners playlist before moving forward. The link to this playlist is in the description below. In addition, I'm assuming that you're also familiar with VS Code, as well as the Julia extension for VS Code. If you're new to VS Code and would like to learn how to use it with the Julia extension, I recommend watching Sebastian Fitzner's VS Code workshop that he presented at JuliaCon 2021. Sebastian is the main developer of the Julia extension for VS Code at Julia Computing, and his workshop is excellent. The link to his workshop video is also in the description below. And that's it. If you know how to use Julia and VS Code, then you're all set. According to Wikipedia, artificial intelligence is intelligence demonstrated by machines, as opposed to natural intelligence displayed by animals, including humans. The concept of artificial intelligence has been around since ancient times, but the field of artificial intelligence research started in 1956 at a summer workshop held at Dartmouth College. The name of the workshop was the Dartmouth Summer Research Project on Artificial Intelligence. The workshop was organized by John McCarthy in early 1955, who was then a 27-year-old assistant professor of mathematics at Dartmouth College. As one of the workshop proposal authors, John McCarthy is one of the individuals who is credited with coining the term artificial intelligence as it pertains to computer science. In 1962, he became a professor at Stanford University, where he remained until his retirement in the year 2000. Sadly, he passed away in 2011, but he is remembered today as one of the giants in the field of computer science and as a pioneer in the field of artificial intelligence. Despite the grand ambitions of artificial intelligence, or perhaps because of it, the field of artificial intelligence has, curiously, come to be known for its dramatic boom and bust cycles. In the late 1960s and 1970s, there was a lot of research excitement surrounding artificial intelligence, leading to overinflated and unrealistic expectations. Unfortunately, the research from this time period did not yield many meaningful practical results. As a consequence, funding for AI research was cut severely in the mid-1970s, leading to a period now known as the first AI winter, which lasted from 1974 to 1980. A second AI winter occurred between 1987 and 1993, and as a field, AI made very few mainstream headlines until the 2010s. Today, we're in the midst of an AI spring, where there is once again renewed interest in the field of AI. It's difficult to pinpoint the exact moment when this current wave of AI hype started, but for investors, it appears to have started sometime between 2010 and 2014. By the late 2010s, the topic of AI had reached mass media, so today, most people have at least heard the term AI, even if they don't fully understand what it is. On January 4th, 2015, Richard Waters wrote an article that was published in the Financial Times entitled, "Investor Rush to Artificial Intelligence is Real Deal," with a subheading of "Startups are looking to offer a new vision of an old idea as investors rush to join bandwagon." In the article, he reports on an unusual wave of investment activity in AI startups, which occurred in late 2014, and he attempts to explain the reasons behind it in order to uncover whether this activity is merely an anomaly or the beginning of a new sustainable trend in AI investments. At the very end of the article, he articulates what he believes to be the key drivers of the renewed interest in AI. Quoting from his article, "The revival of interest owes much to machine learning, an approach that deliberately steers clear of analogies with human thinking. Machine learning is a product of the collapsing cost of information processing and the masses of digital data that can now be gathered and channeled online. Probabilistic techniques are used to train machines as they churn through the data until they are able to see patterns and reach conclusions that were not programmed in at the outset. A subset of machine learning, known as deep learning, accounts for much of the latest excitement. Deep learning draws on another idea from the history of AI, neural networks, or software that seeks to emulate the processes of the human brain to learn more quickly. So his conclusion was that the wave of investment activity that he observed at the end of 2014 was the beginning of a sustainable trend in AI investments, and that the renewed interest in AI was coming from something called machine learning, and more specifically, something called deep learning. Okay, so now that we know one reporter's opinion, What exactly is machine learning and deep learning, and how are they related to AI? Before answering the question of what is machine learning, let's take a look at one organization's answer to the question, what is artificial intelligence? Gartner is a US based technology research and consulting firm. Every year, the firm publishes a so called hype cycle, which tracks various emerging technologies. In 2019, they began publishing a hype cycle specifically for artificial intelligence. Their most recently published hype cycle is from July 2021. The underlying assumption on this graphic is that emerging technologies begin on the left-hand side and move along a so-called hype cycle curve over time. Along the way, the technologies go through different phases, ultimately ending at the plateau of productivity, where it's no longer considered an emerging technology and thus becomes a part of everyday life. There's no data behind this hype cycle, so it's been criticized for being an unscientific, highly subjective representation. With that said, I think that it's still a good starting point for having a general discussion about AI. You probably can't read all of these labels on the screen, but there are a lot of different technologies that fall under the artificial intelligence umbrella. I'll read out a few of them so you can get a flavor of what Gartner considers quote-unquote artificial intelligence. Physics-informed AI, composite AI, machine customers, neuromorphic hardware, smart robots, natural language processing, chatbots, autonomous vehicles, computer vision, and semantic search. I've heard of some of these, but to be honest, I haven't heard of most of the technologies that are listed here, especially those listed on the far left-hand side of this graphic. You can see why I did entitle my tutorial series Intro to Artificial Intelligence, since there's no way I could possibly cover all of these subjects in a 13-part series. But I will highlight two of the emerging technologies that are listed here: machine learning and deep learning. You can see that machine learning is in the so-called trough of disillusionment, and deep learning appears to be close behind. This means that Gartner believes that as of July 2021, the hype surrounding both machine learning and deep learning had mostly subsided, so the world can now begin to form more realistic expectations about what may or may not be accomplished using these technologies. The other takeaway from this graphic is that Gartner considers both machine learning and deep learning to be part of artificial intelligence. We'll see in a few minutes that not everyone shares this point of view. Okay, now that we've seen one organization's opinion regarding artificial intelligence, machine learning, and deep learning, let's take a closer look at a more general definition of machine learning. According to Wikipedia, machine learning is the study of computer algorithms that can improve automatically through experience and by the use of data. Machine learning algorithms build a model based on sample data, known as training data, in order to make predictions or decisions without being explicitly programmed to do so. In other words, rather than having a programmer write code to tell the computer exactly what to do, the programmer makes an algorithm available to the computer, and then the computer figures out what to do on its own. Hence the name machine learning.
Wow!
On the surface, this may sound like science fiction, and you can see why some might consider machine learning to be part of artificial intelligence. But if you examine it closer, is machine learning really the same as intelligent behavior? Going back to the Wikipedia article on artificial intelligence, quote, "Artificial intelligence is intelligence demonstrated by machines." A lot of what's considered machine learning is really just some math combined with numerical computing, which doesn't really meet the threshold of intelligence demonstrated by machines. In fact, much of what's considered machine learning is similar to topics that I covered in my analysis series a year ago. Part of the confusion between artificial intelligence and machine learning is there are at least two different points of views within the AI community regarding the relationship between AI and machine learning. There is one point of view that machine learning is a subfield of AI, and that deep learning is a subfield of machine learning. There's another point of view that not all of machine learning is part of AI, but that only an intelligent subset of machine learning should be considered AI. According to Wikipedia, machine learning learns and predicts based on passive observations, whereas AI implies an agent interacting with the environment to learn and take actions that maximize its chance of successfully achieving its goals.
What?
Confused? Don't worry, so are a lot of other people. Since this is still an emerging field, I'm sure that these discussions will evolve over time. Whether you consider machine learning to fall completely under the AI umbrella, or just partially covered by AI, there's no denying that machine learning has developed into a distinct field of research and practice. The term machine learning was coined in 1959 by Arthur Samuel, who was another pioneer in the field of artificial intelligence. He is perhaps best known for creating a checkers playing program, which was an early example of a self-learning computer program. Coincidentally, in 1966, he became a professor at Stanford University, where he was a contemporary of John McCarthy. Samuel continued to work at Stanford until his passing in 1990. In the 1990s, work in machine learning shifted from a knowledge-driven approach to a data-driven approach, which led to programs using computers to analyze large data sets to quote-unquote learn from the results. In 1997, IBM's chess-playing supercomputer, named Deep Blue, beat Garry Kasparov in a 6-game match. At the time, Kasparov was the reigning world chess champion. The event attracted worldwide media attention as it was an easily digestible story that appealed to a general audience. While the event turned out to be a great PR stunt for IBM, albeit at the expense of Garry Kasparov's reputation, it wasn't necessarily the spark that led to breakthroughs in machine learning. In 1998, a less publicized event took place, which is arguably a more significant event in the history of machine learning. That year, a team led by computer scientist and deep learning pioneer Yann-Luc Han released the MNIST database, which is a dataset of handwritten digits. MNIST stands for Modified National Institute of Standards and Technology. Since its release, the MNIST database has become the benchmark for evaluating handwriting recognition by computers, which is made possible due to advances in machine learning algorithms. Another milestone in the history of machine learning happened in 2009 with the creation of ImageNet, which is a large visual database containing more than 14 million images and labels. ImageNet was created by computer scientist and AI researcher Fei-Fei Li, who was an assistant professor at Princeton University at the time. Since its release, ImageNet has become a proving ground for researchers to show off their latest and greatest machine learning algorithms. As an aside, Fei-Fei Li is currently a professor of computer science at Stanford University. If you haven't figured it out by now, Stanford University has been highly influential throughout the history of AI, machine learning, and deep learning. Speaking of Stanford, no discussion regarding Stanford, AI, machine learning, and deep learning would be complete without mentioning Andrew Ng. Andrew Ng is perhaps the best known public face of AI, machine learning, and deep learning today. Like a lot of Silicon Valley personalities, his career blurs the line between teacher, researcher, entrepreneur, and investor. He is currently an adjunct professor at Stanford University, and he is well known for his online courses in machine learning. In addition to his teaching and researching credentials, he is also a co-founder of the online education platform Coursera. He also worked at Google, where he founded the Google Deep Brain Learning Project, and is credited as one of the key individuals responsible for transforming Google from being a search company into an AI company. He also worked at Baidu as chief scientist, where he conducted similar AI research activities. Meaning no disrespect, for those of you who are not familiar with the company, Baidu is like the Google of China. So his work at Baidu also helped transform Baidu from being a search company to also becoming an AI company. And if that wasn't impressive enough, after leaving Baidu in 2017, he started a company called Landing AI, which provides AI-related services. And in 2018, he launched the AI Fund, which raised $175 million to invest in AI startups. That's a lot for anyone to accomplish in one lifetime, but he's only in his mid-40s, so he's still relatively young. He's clearly at the center of the current AI hype, so it should be interesting to see how his career progresses, since everything he does is somehow closely tied to AI, machine learning, and deep learning. So, with that brief history of machine learning, that brings us to the present day. If we go back to the Wikipedia article on machine learning, you'll see that machine learning is really just a collection of algorithms. An algorithm is just a set of instructions for your computer. There's no universal machine learning algorithm. Instead, the name of the game is to pick the best algorithm for the task at hand from an ever-growing list of algorithms. These algorithms are grouped into various categories. If you click the Show hyperlink, you can see the names of the algorithms for the various categories. Broadly speaking, machine learning approaches are traditionally divided into three categories, which are known as supervised learning, unsupervised learning, and reinforcement learning. According to the Wikipedia article on supervised learning is the machine learning task of learning a function that maps an input to an output based on example input-output pairs. It infers a function from labeled training data consisting of a set of training examples.
What?
Did any of that make sense to you? Let me try to describe it in a slightly different way. So in a typical non-machine learning problem, the user provides the inputs and the function, and then it's the computer's job to figure out the output. Supervised learning rearranges that workflow. With supervised learning, the user provides the input and the outputs, and then it's the computer's job to figure out the function.
What?
So you may be wondering, if you already know the outputs, then why would you care what the function is? Well, there are many situations where you have a lot of historical data that shows inputs and outputs, but it's unclear how they're related. So if you obtain a new input, there's no way for you to make a prediction about an expected output unless you can figure out a function that converts those inputs into outputs. In many cases, it's not humanly possible to manually figure out that function. That's where supervised learning comes in. Rather than trying to figure out the function manually, you can have your computer try to figure it out for you. Some examples of supervised learning applications include handwriting recognition, computer vision, spam detection, and speech recognition. Between supervised learning, unsupervised learning, and reinforcement learning, supervised learning is arguably the most mature and has shown the most commercial success so far. In this tutorial series, we'll be spending most of our time with supervised learning. Unlike supervised learning, unsupervised learning relies on input data only. According to the Wikipedia article on unsupervised learning is a type of algorithm that learns patterns from untagged data. In other words, with unsupervised learning, you run raw data through an algorithm to see if your computer can find some pattern in the data that perhaps may be too complicated for a human to see. An example of unsupervised learning is the infamous YouTube algorithm. Back in 2016, Google released a white paper that provided a high-level explanation about how their YouTube recommendation algorithm worked back then. In the paper, the authors provide insights into how they utilize machine learning to serve recommendations to users. Prior to the use of machine learning, YouTube was really just a platform where users could host video files. People would find out about popular videos from their friends, coworkers, or some other external source, and then they would go to YouTube to look for that one specific video. After YouTube implemented machine learning, people started watching videos served up by the YouTube recommendation feed rather than relying on external sources. As a result, viewer watch time increased dramatically as viewers started to watch videos that they would never have searched for. While this may have been great for YouTube, I think the jury is still out regarding the algorithm's overall impact on the platform. I'm sure that all of you can relate that sometimes the videos recommended by the YouTube algorithm can be baffling, and for many content creators, the YouTube algorithm is a source of ongoing frustration. For regulators, the YouTube algorithm is troubling due to its lack of transparency and lack of accountability. I will be covering unsupervised learning in this tutorial series, but I will not be spending as much time on it compared to supervised learning. The final category that I will be covering in this series is reinforcement learning. According to the Wikipedia article on reinforcement learning is the area of machine learning concerned with how intelligent agents ought to take action in an environment in order to maximize the notion of cumulative reward. Between supervised, unsupervised, and reinforcement learning sounds the most like the definition of artificial intelligence. You may have seen YouTube videos allegedly showing an AI that's learning how to play video games. Those videos are examples of reinforcement learning. Reinforcement learning is also used in robotics. Relative to supervised learning and unsupervised learning, the objective of reinforcement learning is fairly easy to understand, so it tends to get more attention from the mass media. While it may be fun to watch a computer learn how to play a video game, there are not a lot of practical applications for this. I will be covering reinforcement learning in this tutorial series, but I will not be spending a lot of time on it compared to supervised learning. Now, what about deep learning? Why wasn't deep learning included in the list of machine learning categories? That's because deep learning is a subfield of machine learning, so deep learning algorithms can also be categorized as supervised learning, unsupervised learning, or reinforcement learning. According to the Wikipedia article on deep learning is part of a broader family of machine learning methods based on artificial neural networks with representation learning.
What?
I know that's a lot to take in, but it's basically saying that deep learning is inspired by the biology of the human brain. I say inspired by since we don't actually know how the human brain works yet. Of everything that we've discussed so far, deep learning is the closest to the definition of artificial intelligence. Deep learning can trace its roots back to the 1960s, but many of the developments have happened recently, so it may be a while before historians can piece together a definitive history. In any event, many researchers have contributed to the advancement in deep learning, but much of the credit for the recent advancements in deep learning is often given to the so-called godfathers of deep learning. In 2018, Yoshua Bengio, Geoffrey Hinton, and Yann-Luc Han were awarded the Turing Award for their pioneering work in deep learning. The Turing Award is like the Nobel Prize of computing. Bengio, Hinton, and Luc Han are often referred to as the godfathers of deep learning for their influence in advancing deep learning during the 1990s and 2000s. Deep learning is a rapidly developing field and is pretty complicated, so I will not be spending a lot of time on it during this tutorial series. I will be covering deep learning briefly under the supervised learning section, but as stated earlier, deep learning may be used for supervised, unsupervised, or reinforcement learning. For this series, I think it's more important to focus on learning the fundamentals of machine learning in order to build a solid foundation. At some point in the future, I'll put together another 13-part series just for deep learning. Okay, that was a lot to take in. So let's take a few minutes to recap what we just learned. AI, machine learning, and deep learning are three distinct fields of study. Deep learning is part of machine learning, while machine learning may or may not be part of AI, depending on your point of view. If someone asks you, what is machine learning? You can tell them that machine learning is really just a collection of algorithms. The difference between these algorithms and your average run-of-the-mill computer algorithms is that machine learning algorithms have the ability to improve automatically through experience and by the use of data. Further, machine learning algorithms may be classified as either supervised learning, unsupervised learning, or reinforcement learning. Since there are a lot of different machine learning algorithms, the objective is to find the appropriate algorithm for the task at hand. Machine learning can be an overwhelming subject, and it's easy to get paralyzed before even getting started. But, like any other subject, the best way to learn something new is not to take things too seriously, and to try to have some fun along the way.
You can do it!
Well, that's all for today. If you made it this far, congratulations! If you enjoyed this video and you feel like you learned something new, please give it a thumbs up. For more Wholesome Julie tutorials, please be sure to subscribe and hit that bell. If you like what I do, then please consider joining and becoming a channel member. New tutorials are posted on Sundays/Mondays. Thanks for watching, and I'll see you in the next video.